Hey guys, welcome to question MM228 of the Maths Methods Fortify study guide. So we've got this function f of x equals negative x cubed plus 2x plus 4. And our first task is to find f dash of x. So as you would know by now, f dash of x is our derivative function or our gradient function, which means all we're going to need to do is just differentiate this f of x function. So this is pretty straightforward. Let's differentiate it as normal. So this 3 comes out the front, so we get negative 3x squared plus 2, and that's it. So this is only a 1 mark question, very, very straightforward. You shouldn't really trip up too much on this. I don't think I need to explain any more about this. If you have any questions, just let me know, but let's just move on to part AII. So part AII is, again, just a 1 mark question, and it says for f, show that f dash of x is less than or equal to 2 for all values of x. Awesome. So the easiest way to do this, guys, is just to recognize what this graph, or what the gradient function graph looks like. So we know that it's a negative parabola because we've got a negative 3x squared, and it's actually moved up by 2 units. So what this roughly looks like is, if we just had negative 3x squared, it would look like this, but because we're moving it up 2, we've actually moved up by 2 like this. So this is at 2, and this is our f dash of x function, right? So this is what our graph looks like. So our f dash of x is less than or equal to 2, and f dash of x is our y value of the gradient function, and we can see that the y value never goes above 2. It's always at 2 or below 2, which means that it's going to be less than or equal to 2 for all values of x. This is really just what you need to do, is to just show this graph and show that the value never goes above 2. But that's it. That's your first and only mark. So let's move on to part B. For part BI, the question tells us the quartic function g of x is defined by g, where g of x is equal to ax to the power of 4 plus bx cubed plus cx squared plus dx plus e. Awesome. And this is 1 mark. And the question tells us if g has m stationary points, what possible values can m have? So m is just a number, and we're looking for the amount of stationary points that a quartic can have, right? Because we know that g of x is a quartic. Now, a quartic can either have 1 stationary point like this, sort of like a parabola. It can have 2 stationary points like this, so that's 1 and that's 2, like that. And it can also have 3, which is our 1, 2, 3 regular quartic. Awesome. So that means that m can be 1, 2, or 3. Can't have 4 stationary points because that would be a to the power of 5, and it can't have 0 stationary points either. So m equals 1, 2, or 3, and that's it. So that's again your 1 mark. So there's a lot of 1 mark question or 1 mark parts in this question, but this is just the 1 mark. For BII, we're asked to explain why for all values of m, g cannot have an inverse function. So for an inverse function to exist, the original function has to be a 1-to-1 function, right? If we make this, let's just take this 1 stationary point quartic, for example. If we were to take the inverse of this, we would end up with a function that looks something like this, right? And this does not pass our vertical line test, which means that a vertical line through any point there is going to have 2 intercepts with the graph, which means that it's not a function, it's a relation, which means that the inverse function does not exist. And this is the same for the 2 and the 3 as well. Regardless of whether it has 1, 2, or 3, we're never going to be able to have an inverse function because these aren't 1-to-1 functions. So that's all you need to say, is just that the original functions, no matter what m is, are not going to be 1-to-1, so the inverses don't exist, and that's your first and only mark there. Let's move on to part CI. So part CI gives us a cubic function. So we're moving on from that quartic there. I'm just going to get rid of this. I don't think I need that, and I don't believe I need f of x. No, I don't need this anymore either. So in part CI, which is worth 3 marks this time, we've got a function h of x, which is equal to 2x cubed plus x squared plus cx plus d. Awesome. And the question asks us, if h has only one stationary point, find the value of c. Awesome. So again, this is a cubic. If this has one stationary point, this means that the gradient is 0 only once, which means that our gradient function only crosses our x-axis only once, right? So if h of x is equal to this, then our gradient function, h dash of x, is going to be equal to 6x squared. This 3 comes down here, take 1 off the power, plus 2x plus c. And that's our first mark right there, guys. So from here, we know that this graph has to intercept the x-axis once. This is a parabola, which means that the turning point is going to be on the axis, right? That's the only way that a parabola can cross the x-axis once. And the way that we find out where that happens is using our discriminant, right? So remember, our discriminant is this little triangle thing, where the discriminant is equal to b squared take 4ac. Now, if this has one solution, as in one x-intercept, the discriminant is going to be equal to 0. That's just one of our rules. So discriminant equals 0, therefore b squared take 4ac is equal to 0. And now, kind of here, or like the start of the next section is where you would get your second mark. And now we just need to sub in our values, right? So this is our a value, this is our b value, or rather this positive 2 would be our b value. And this would be our c value. So that just happens to be the same c. Awesome. So now all we need to do is just sub in our values. So b squared, where b is 2. So I'm just going to say 0. So this 0 I'm just putting on the other side. So 0 equals b squared, where b is 2. So 2 squared minus 4 times a, which is 6, times c, which is just c again. 2 squared is 4. 4 times 6 is 24, so 4 take 24c is equal to 0, which means 24c equals 4, therefore c equals 4 on 24, which equals 1 on 6. That's our third mark. And that's all we have to do. So keeping in mind that the question is asking us for the value of c, and that's what we found. So c is equal to 1 on 6, and that's our final answer. Let's move on to part CII. Part CII says if this stationary point occurs at the point of intersection of y equals h of x and the inverse of h of x, find the value of d. Cool, so we're still dealing with this same cubic, but now we actually know what c is, right? We know that c is equal to 1 on 6. Cool. And we're going to search for our d value. Awesome. Don't need this, and we don't need... Oh, I might leave that there. I'll just replace c with 1 on 6. So we still know that our derivative function is 6x squared plus 2x plus 1 on 6, now that we've found c. So if this stationary point occurs at the intersection of a function and its inverse, that means that the x value is going to be exactly the same as the y value, right? Like, let's say that we had a square root function, for example, that went like this. The inverse of that is flipped across the y equals x axis, right? So we're going to have something like that. This point here is on the y equals x line, which means this coordinate is going to have the same value for both x and y. So that's something that we're going to have to take into consideration here, but just keep that in mind as we go along. So we know that our derivative is equal to this, and we know that the stationary point is what we're looking for, right? So we know that h dash of x is equal to 0 because it occurs at a stationary point, and we're going to use this to find our x value of where this occurs, which means that 0 is equal to 6x squared plus 2x plus 1 on 6. Now, according to Kaz, our x value is equal to negative 1 on 6. And this is like the recognition that the y and the x value are going to be the same is sort of your first mark. So like as you go along here, your second mark is finding the x value of the stationary point. And then because x is equal to negative 1 on 6, and it's at the point of intersection between the function and its inverse, y is also going to be equal to negative 1 on 6, right? Because they have to be the same. So from here, we know that h of x is equal to 2x cubed plus x squared plus 1 on 6x plus d. Now we have a coordinate, so we know that the x value is this, the y value is this, so all we're going to do is simply sub in our x and y values, and then we're going to get d, right? Because we're going to have our y values, our x values, and we're going to solve for d after that. Plus negative 1 on 6 squared plus 1 on 6 times negative 1 on 6 plus d. And then from here, I would just simply solve this in my CAS because I don't want to do this by hand and you shouldn't either. So therefore d is equal to negative 17 on 108. And obviously because we didn't get asked for decimal places, this needs to stay in fraction exact form. That's our third and final mark, and this is our final answer. Guys, if you have any questions, please hit me up in the comments below. But otherwise, have a great day and thanks for watching.